Hey, I'm Dave Baszucki, and this is Tech Talks. We're covering the people and ideas that are shaping the future of human interaction and exploring this exciting new category of human co-experience that we're building at Roblox. Today, I'm hanging out with John Stauffer, VP of Engineering for our Engine Group. We're going to be diving into not only all things engine, but a little background on physics simulation, rendering, spatial audio, really all of the supporting tech that helps us simulate the real world. John, thank you. Great to have you here.
Good to be here, Dave.
Yeah, it's wonderful. This is the first time we have ever done this live, so thank you for joining us in our new setup. I want to roll the clock back a little. Try and remember, you've been here less than a year, right?
Yeah, 7 months.
Okay.
It went fast.
It seems like 1 month.
It does. It went very fast.
We had that initial meeting where we hung out at a restaurant, I believe, and we were talking about all of the components of trying to simulate the real world on Roblox. And I found this amazing overlap with your history because we were talking rendering, audio, graphics. Can you just share a little about what you were doing before Roblox?
Sure. Yeah, I had a wonderful opportunity at Apple. Steve bought my graphics company to bring professional 3D graphics to Apple in 1999. And that really started, the venture that we were on then was to really take GPUs and make GPUs into a mainstream computing device. And that wasn't a thing before that time period. Like GPUs barely existed. They could do only simple things. And so we went on a journey to make GPUs usable with the operating system for rendering the UI, image processing, video processing. Then it goes into general computing and shaders. And of course, we all know now it's a powerful device for AI and just about everything that you want to compute. A GPU is there to do it.
Okay, so from the outside in, when you saw what we're working on at Roblox and the vision, one of the big visions of Roblox that could arguably be a multi-decade vision is the more we simulate the real world, the easier it is for creators to build. Can you talk a bit about that?
Yeah. I mean, that is the vision. The vision for us is to simulate the real world using real world constructs.
Yeah.
And when we use real world constructs, what that means is that as we get better at simulating the real world, we can just make these constructs work better for every game that is out there.
That's right.
And that's one of our core visions is abstract the world in real world objects and enable us to do the best we can in simulating. And that will scale with the device. So we can run on low-end devices, high-end devices, and have different fidelities of simulation. It also enables us to leverage our cloud where we need to in leveraging cloud infrastructure for supporting our ecosystem and our simulations.
Yeah, there's an interesting analogy that happened in the mechanical engineering software market where most people who play 3D experiences might not know it, but a lot of what they're playing with are almost hollow, visually looking things called meshes and textures that look very good. But if you look behind that, there's really nothing there in a sense. And in the mechanical engineering world, where people need to figure out, will a car work? Will a aircraft fly? Will a bracket break? They go well beyond that. They simulate the materials these objects are made of. It's not just a hollow thing, it's made of steel. That allows you to do a lot of things. And that's been an interesting principle at Roblox, where if a developer has a part made of wood, for example, that's something that ultimately we're going to be able to drill. It can accidentally catch on fire. It's something that will look better and better over time. And our hope has been that when people use these real world components, it's easier to build. It's more intuitive when the wheel falls off the car that it's just not going to work.
Right. Yeah, it's a big differentiator for us where we're building experiences out of real world materials and real world objects, and as opposed to other simulation engines, they are pure meshes that don't have the material properties that are trying to interact with the world in a realistic way.
Yeah, so when we dive into the uniqueness of Roblox, it's not always apparent from the outside world, but this notion of simulating the real world, arguably UGC creation is somewhat difficult, and it's somewhat difficult for 2 million people to make stuff on a platform like this. Can you chat at all about why simulating the real world might make that easier?
Yeah. Yeah, our goal is to be able to enable in-experience collaborative creation, content creation, and to be able to create any types of objects with time. But what makes it what we bring to it that makes it easier is that with the real world material properties, if you want to machine it or to burn it or to cut it, it'll behave like a real material. And so that's just a very instinctual way of interacting with objects that we all know is how the real world works. And so we're trying to bring that realism to these experiences to enable creation in real world objects and materials, and it just makes it an intuitive experience.
Yeah, so let's, one thing that I think is near and dear to your heart is acoustic simulation. And I want to chat about that as well. The voice system that we've introduced at Roblox, the early version of it, is something we call spatial audio. And could you explain maybe the difference between traditional 10 people on a phone call audio versus spatial audio?
Yeah. Well, most audio systems, they are purely my voice, maybe with some noise reduction going straight to you. What we're enabling it such that you are speaking in a real world, and the reverb from the materials around you, the way the sounds in that acoustic environment, we're simulating that. We're going to be simulating that. And the person on the other end will hear your environment.
That's right.
And it'll be a fully simulated 3D spatial acoustic environment.
So there's something really subtly interesting about that, in that if we put 100 people on a video call right now and we try to have them hear everyone else, that I assume would end up being 100 people chatting at the same time. Whereas when we put 100 or even 1,000 people in a 3D experience, for some reason I'm able to hear the people closer to me, even in the din of everything. Can you maybe share a bit about what n-squared fall off is and why that works?
It's an important concept for simulating the real world. Like, you want it to be intuitively make sense why I'm hearing what I'm hearing.
Yeah.
It's utilizing the fact that we are defining the world in real world objects with real world materials, and not just mechanical materials, but acoustic properties as well. So our creators can create experiences. They will be building with objects with acoustic properties. Those acoustic properties are going to then make the sound unique for that experience and give you a very realistic sense of that experience.
So hey, let's chat a little about scale, because arguably a lot of people who use Roblox think it works really well right now. And at the same time, for 10 years, I've been saying we need to simulate a 50,000 person concert. Do you think we need to do all that extra work? I believe we do.
Yeah. It's a challenging problem. It's one we are designing for, right? Yeah. We know we have some steps to take, right? But we're building the foundation of the architecture that'll enable us to continue down that road to get to that point. But it's a journey, and it's going to be an adventure for us.
Now, one thing that's interesting about scale, if we start thinking about simulating a live gathering of 50,000 people, there's visual simulation, audio simulation. Conceivably, that is a simulation that cannot run on a single computer at all. We have we've luckily, and I think thoughtfully as well, taken the notion from very early on, we want to run our own infrastructure. So we have a lot of data centers, a lot of servers. When you imagine that 50,000 person simulation, can you share, is that running on one machine? I'm assuming it's running on a lot of different machines.
Right. And that is one of the challenges for us, and something that I don't think anyone else has done, which is the ability to scale not simply on a single device, but a cluster of devices to be able to simulate very large co-experiences. And it is a really challenging and but something that is going to make our experiences unique.
Now, one thing we did very early on at Roblox is we had some early decisions, and I think it was literally DirectX 9C or something. I don't know if that's familiar or if that was like my memory's fuzzy,
Yeah.
but I remember having to make a decision at what point we would make that the cutoff, and we really held out for a long time because we knew there were a lot of people around the world with low-end, really bad devices. And we always kept, I think, a little bit of a philosophy: let's work on very low-end devices and then accelerate on higher-end devices rather than just, cut the threshold. I think that's a more difficult engineering problem as well.
Yeah.
Could you share a bit about the difficulties in doing that?
Yeah. We support up to 10-year-old devices. They could be very low-end devices from 10 years ago. So that's a very challenging problem. And that really means that we need to be thoughtful in how we build our systems, how we can scale our systems. We want to be able to scale all the way from low-end, all the way up to high fidelity. And that is our goal. That's our mission.
So one area we've also been really diving in deeply is our avatar tech. This has been a huge effort over the last few years. We have, we're always going for combinatorial excellence. Could you highlight a few of the areas of avatar tech that we shipped and what we've announced that's coming?
Yeah. Well, first off, I think it's important to realize also that we make avatars out of the same materials as the rest of the world, so they interact with the physics models the same way that any other object.
I think that's a key thing, actually, because in the very first version of Roblox, the avatars were so similar to the real world. There's a lot of weird hacks where people could glue part of the real world onto their avatar, and a lot of weird stuff would happen.
Yeah.
But that philosophy is still here today.
That's right. But to your question of like what are we doing in avatars? I mean, we talked previously. We've announced layered clothing. We're really now leaning into higher fidelity avatars, user-generated, user-created avatars in experience. We of course are really going after AI in this space and generative AI for avatars, for assets, and everything that you may want to create. Now, of course, there's a roadmap of time that we'll be working on these things, but avatars are just getting more and more realistic in terms of facial animation, being able to chat with avatars, being able to be expressive with your avatar, being able to personalize it. A lot of really interesting directions we're taking avatars.
But if I went to certain people in my life and said, hey, I want you to design a new dress in Blender or whatever, they say, no way. If we went to the next level and said, hey, I'd like you to use scissors and a sewing machine to design a new dress, a lot of people might say, oh, I think I can do that. And a lot of people will say, I don't think I can do that. But if we said, hey, you're going to go to a virtual fashion shop, you're just going to sit there and talk to a consultant. And when you're talking to that consultant, you're going to say, okay, I want to start fabric a little heavier, a little more blue. I'd like some trim tighter on the waist. All of a sudden, I can imagine everyone designing clothing.
That's right. That is the world we're heading to.
Yeah. Now, there's another subtle thing we talk about, which is, does this happen inside Roblox Studio? Which is, well, that's the big development tool you use. Does this just happen in Studio?
No, of course, our roadmap is that we want it to be an experience, right? We want it to be a collaborative user experience. People come together, people can be creative together. They can use these incredible, powerful tools that we're going to be building to create together. It's going to be like nothing we've seen before. This content, this creation process is super exciting.
Yeah, and we're starting to see fashion designers already. Parsons School did a a project with us. Starting to see fashion design happen digitally. We're starting to see fashion trends first happen digitally. And I do think there will be a place where these people I mentioned in my life design their own clothing in places in Roblox and possibly have it manufactured.
Yeah. Yeah, and what's really interesting about this is that there's a lot of technology even behind what you see. So for instance, people will enable people to create clothing, but then the clothing needs to fit the avatar, being able to fit it, to make it fit whatever avatar you've created. And the same goes with creating avatars, being able to create avatars and then have them automatically be enabled to be expressive, to be enabled to move and have motion that looks realistic is all driven by AI underneath.
And that's a lot of tech, because when creators build clothing on Roblox, it works everywhere.
That's right.
Historically, even before Roblox was started, some of the founders, Eric and myself, really worked a lot in physics simulation. And Knowledge Revolution, the company before Roblox, was literally a physics simulator. The product we then moved on to, Working Model, was a very high-end physics simulator, simulate car suspensions, simulate how an old-fashioned camera would work, simulate those types of things.
Yeah.
And we fast forward to that being in Roblox, running in the cloud, and now we keep pushing forward on the types of simulation we've done. One thing we've been talking about forever, and we started showing and is going to go live, is how do we simulate aerodynamics?
Right.
And for those, there's two types of flight simulators out there right now. X-Plane is one, Microsoft Flight Simulator is another. In X-Plane, for a long time, when someone would design a plane, they would design the shape, the flaps, the speed, the thrust, and the performance of the plane actually was done through a physics simulation, which is really quite satisfying, because if you or I were to make a new airplane, we just design the plane and it just works. They're simulating the airflow over those flaps. I don't know where Microsoft is on that, but I do think this is a radical trend. Fast forward to Roblox aerodynamics, and there's a little bit of a fun connection there.
Yeah. Yeah, there really is. And I'll say that we are taking it to the next level. We are taking real aerodynamics equations and figuring out how to evaluate, how to quantize the object into a somewhat simpler model we can run real time. But it's using the Navier-Stokes aerodynamic equations as the starting point for those. So it's real flight, it's real aerodynamics.
So this is something that was almost a design spec for this, but if I make, there's a lot of helicopters on Roblox, and they've been around for 10 or 15 years, and historically, to make them fly, people have written code. Here's a script, here's how the helicopter could fly. Can you share maybe how a new helicopter on Roblox will work?
Right. So as we talked about, what we're trying to do is build objects out of real world materials and have them behave like real world in a simulation. And so when you build a helicopter, you are just building a helicopter with blades that turn. And those turning blades generate uplift. So it's aerodynamic forces that are making the helicopter fly. No special code needed. They can do this just by building the helicopter or airplane, and it should fly.
Now, what I would hope is if people build a helicopter without the rear blade that counteracts torque, we would see that helicopter fail. Is that the case?
Yeah, that's a great question. This is all degrees of fidelity, and we're continuing to build out fidelity.
That's right.
Yeah, and with time, we'll get more and more of these real world cases working.
I guess I'm pretty much intuitively am quite sure that will happen on Roblox, because we're putting diagonal forces on those blades that lift and torque.
That's right.
So what's going to be really exciting once again in Roblox is if you're in a helicopter and you're in a simulation that's a little edgy, and for some reason that blade falls off the back of your helicopter, you are going to do a weird auto rotate if you want to try and land that helicopter.
That's right.
Okay, and so I think that also means if I drop something from the top of a building, it's not going to accelerate forever. It's going to kind of reach its maximum terminal velocity as well.
That's right.
Okay, super cool.
That's right. That'll be seen with trees, with leaves falling from trees, and the leaves will float down as though they would in the real world, for example.
So one other area that's very big right now, and I would argue that the slope of innovation on AI is eclipsing many of the things you and I have seen. We've seen the slope of innovation on NFT and blockchain. We've seen the slope of innovation on mobile. We've seen the slope of innovation on social. We've seen the slope of innovation on web. It's really going fast.
That's right.
Right now. And we started sharing our roadmap. We've shown what we're doing with generative code generation, which is awesome. We've shown what we're doing with generative material generation. But could you, how big is this? What's the big perspective here?
Yeah, it's massive. It's going to be, as we talked a bit about, user-generated content. It's going to be fundamentally a game changer for user-generated content. But it's also going to be a fundamental game changer in terms of what we do in the simulating real-world effects, simulating various physical attributes. Motion and physics will also start leveraging AI to be more realistic. Of course, it's also used in our moderation to keep our experiences safe and civil. So it's really used in every major area of Roblox, and it's going to be a game changer for us in each of those areas.
You know, one thing I'm really excited about is once again, a privacy and user opt-in compliant way, there's amazing opportunities to use historic data to make these models work better. And one thing, when we think about generative models on Roblox, when we talk about digital matter and avatars being made of bones, and a tree made of wood, and a car made of metal, and connecting axles and all of that, these start to be objects that are not just visible, they're physical objects. I'm really excited about the idea of using generative AI, not just to visually make things, but to make them in native Roblox format, which is functioning objects as well.
That's right.
What do you think?
Yeah, no, and that's one of the keys, is that when we generate something using AI, it will have to be constructed in a way that delivers the experience, the realism in the experience of that actual object. And some of that will be specific to how Roblox needs it formatted and how we need to construct it such that it behaves appropriately within that world. So it's quite complicated that way, that there is all of these requirements in how we generate content.
And a lot of the content on Roblox includes both what we would call digital matter as well as embedded code. So if I give you a new Ferrari on Roblox, I'm giving you something, once again, with rubber wheels and axles and a motor, but I'm also giving you something with code inside of it. Code that might figure out when I get near to it, do I sit in it, that puts up the driving panel, all of those kind of things. I think what's really exciting is the opportunity to use generative AI to generate rich 3D models that include code and digital stuff as well.
Right, behaviors.
That's right.
Characteristics.
Yeah.
Yeah.
Can we talk a little about on the avatar side where you think this may go?
Yeah.
And right now, arguably, the avatars on Roblox are very responsive. They're starting to track our face and our head. But with AI, and as we improve the quality of our avatars, how far out do you think this might go?
Yeah, well, it's certainly going to be a key component of movement and behavior and expression, certainly as we talked about in terms of the creation experience of being able to personalize and customize your avatars. But with time, as we look out, AI is going to start being in just about every function or anything we're trying to do with avatars. It's so fundamental to our ability to create and to simulate real world objects and organic objects like avatars.
been quite interesting hanging out with you. I appreciate you speaking with the Tech Talks audience today.
Yeah, thank you for having me.
Okay, thanks, John.
Yeah.
So hey, this is Dave Baszucki. Thanks for joining us on Tech Talks and another interesting, really interesting first visual episode we've ever done, by the way. Thank you all.
Thank you.
Thanks, John.
Yeah, thank you. It's awesome.